An object is moving so that its speed after t minutes is v of t, which is a function. Meters per minute. How far does the object travel during the third minute? So this is the question. So before we get into the problem, let us discuss about few terms. First term which we are going to discuss is the displacement. Displacement, as the term itself indicates, the change in position, the change in place of any object will be called as displacement. Okay, and then we are going to discuss about velocity. Velocity, as we all know, it is nothing but the speed. That is, it is the rate at which the object is moving from one place to other, or else the rate of change in position of an object. That is nothing but rate of change of displacement of an object, which is nothing but the velocity. Okay, now we are going to find out how far does the object travel during the third minute. So during the third minute, in the sense, it is the small interval which lies between the second and the third minute. That is after the second minute, okay, till the third minute gets completed. So that duration, in that duration, how much distance is the object going to travel? This is our question. So we are given the speed with which the object is moving. So this is nothing but the velocity of the object, which is nothing but the rate of change of displacement. So we are given the rate of change in position of an object. So we know very well that velocity is nothing but the differential of displacement, that is the derivative of the displacement. So we can identify the displacement by integrating the velocity. Okay, so after identifying the displacement, that is from one position to the other position, the object is traveled with a certain distance. That distance we will be able to identify by using displacement. Using that displacement, we will identify how long does the object has traveled during the third minute. Let's get to start. So since we all know that the velocity is the rate of change of displacement, we are denoting the displacement as s of t. So we can identify the displacement by integrating the given velocity. So let's integrate. Integral 1 plus 4t plus 3t square dt. Okay, basic integration of an algebraic function. We are having three terms here, so each of the term has to be integrated. So let's integrate. So this is integral 1 dt, or simply integral dt, plus integral 4t dt plus integral 3t square dt. Okay, let's integrate it. We know this is an integral dt, which means integral t power 0 dt. So when we integrate it, it will be just t for us. Okay, plus 4 into integral t. So the constant, that is the coefficient 4, will have it as it is. Integral t dt will be t square by 2 plus 3 into t square dt will become t cube by 3 plus the integral constant c. Okay, now let's simplify it here. This will be 2 1 times, 2 times, 3 and 3 gets cancelled. So what's pending? We are having t plus 2t square plus t cube plus the integral constant c. This is nothing but the displacement, that is from the initial position, okay, to the final position, the object has traveled so much distance. Okay, I repeat once again. If this is going to be the initial point and if this is going to be the final point, from this position to this position, the object has traveled this much distance at time t. Okay, this is nothing but the displacement. Okay, now we are going to identify how far does the object travel during the third minute. That is, during the third minute, how much distance it is going to travel. Okay, so now let us identify till the third minute how much distance does the object go, then till the second minute how much distance the object goes. When we subtract both, we will be able to identify the travel distance during the third minute. Okay, for example, from the initial position till the final position, okay, if we are able to identify the distance as some capital X, okay, this will be nothing but the duration of 3 minutes. Okay, 3 minutes duration the object is traveling so much distance. Then we will identify in 2 minutes how much distance it is able to travel. Let that be some y. Okay, during the third minute, in the sense that is only for that third minute how much distance is it traveling. So from here till here, that is going to be the travel for the third minute, during the third minute. So let us subtract the entire distance traveled in total 3 minutes and the distance traveled in the 2 minutes. When we subtract both, we will be able to identify the distance traveled during the third minute. This will be the distance traveled during the third minute. Let's identify that. So distance traveled in 3 minutes, S of 3, that will be, just in the place of t substitute 3, that's it. This will be 3 plus 2 into 3 square plus 3 cube plus the integral constant. This is 3 plus 2 into 9, 18 plus 3 cube 27 plus the integral constant. So this will be 18 plus 3 plus 27, 48 plus the integral constant. That's it. This is nothing but the distance traveled in 3 minutes. Now we are going to identify the distance traveled in 2 minutes. So distance traveled in 2 minutes, S of t will be, in the place of t everywhere substitute 2. That's it. So this will be 2 plus 2 into 2 square plus 2 cube plus the integral constant. So this will be 2 plus 2 into 4, 8 plus 2 cube, which is 8 again, plus c. So 8 plus 8 plus 2, which will be 18 plus the integral constant. So this is nothing but the distance traveled in 2 minutes. Okay, now we are going to identify the distance traveled during the third minute. During the third minute, in the sense from the end of the second minute to the end of the third minute. That's it. That's going to be the distance traveled during the third minute. So let's subtract both. Yes, S of 3 minus S of 2. Distance traveled in 3 minutes minus distance traveled in 2 minutes. So 48 plus the integral constant minus 18 minus integral constant. That is minus of 18 plus c. So plus c and minus c gets cancelled. 48 minus 18 will be 30 meters. So 30 meters is the distance traveled during the third minute. That's it. Okay. Thank you.